Collisions, momentum, impulse.
Yes, so the first part, as I see, you're on the whiteboard. Starting from
Yeah.
question number 1, it's about impulse and momentum in 1D. So do you want to start there?
Yeah, but I mean, the formula is pretty straightforward. It's just velocity times the mass.
Yeah, that's what the momentum is. And how about impulse?
Impulse is the change in time.
Change in time? No. Change in time would be a measure of time, right? You're on the whiteboard, right?
Yes.
Okay. Impulse is equal to the change in momentum.
Yeah.
So it's essentially equal to the final momentum minus the initial momentum. Okay, got it?
Yeah.
Okay, now remember Newton's second law of motion?
Yeah, it's with mass and movement.
The second law tells us that the force acting on a body is the product of its mass and acceleration. That's one way to say it. Or it's also equal to the rate of change of momentum. In other words, it's the change in momentum of a body divided by time. The time taken to bring about that change. You want to understand how this works? You need to break this one down, the A. Now what is the definition of A?
Acceleration?
Acceleration, which means it's the final velocity minus the initial velocity divided by the time taken. Am I right?
Yes.
Now if you distribute the m, that is multiply m with this and with this, you get mv, the final momentum, minus the initial momentum divided with t.
Okay.
Let me know if that makes sense.
Yeah, that makes sense.
Right? So then this part out here is the same as the impulse. You see that? The final momentum minus the initial momentum.
Yeah.
So therefore we have force. Force acting is equal to the impulse, the change in momentum, over time. And if you bring the time over to the other side, that is cross multiply, you have impulse is equal to the force acting multiplied with the time duration during which the force acted. So you have two definitions of impulse. One is this and the other one is this. Final momentum minus initial momentum, and that's the same as force multiplied with time. Have a look, let me know if you have any question before I clear the whiteboard.
Okay, I got it.
Sure?
Yeah.
Okay. Over to number 5.
Yes.
Okay. You're trying it, right?
Yes. I got 88.
Oh, you got the number? I was not looking at the numbers actually. Can you tell me how you found it out? Part A.
So I did the mass times the final velocity minus the mass times the initial velocity.
And that gave you the answer to part A?
Yeah, that gave me the the change in momentum.
Okay. You got it right, but then there was a better way to do it. Instead of doing 2 multiplications, why not subtract the velocities, 28 minus 6? So it's about mass times the final minus the initial velocity. So my idea is, if I were in your place, I would write it 240 times 28 minus 6. That's 22. So I need to do only one multiplication. 240 times 22. Does that make sense?
Yeah, that does.
Okay, fine. How about part B?
For part B, it would be 5,280 divided by, well, which is force times time, and then you would find force, which is 88, and then you multiply that by time, so it's just 88 times 60.
Wait, where did you get the 88 from?
That would be the force, because, oh wait. The final velocity minus the initial velocity divided by time times the mass.
Part B, right? Are you
Yeah,
talking?
for part B.
Yes, okay. Part B is about finding the impulse. Now I gave you two definitions of impulse. One was force times time. The other one was change in momentum. So don't you think the change in momentum is already what you figured out in part A?
That would be the same answer.
Yes, part A and part B would have the same answers. This and this are the same. Change in momentum is equal to the impulse, right?
Yeah.
Okay. How about part C? What's the average force?
That would just be the impulse divided by the time.
Yes. Divide this with 60. Got it. You want to have a look at number 6?
Yeah.
Okay.
So it would be the final times the mass, which is 0 because it's stopped, and you subtract it by the kilograms times the initial velocity, and you divide that by the time.
Excellent. You got it.
But what would be the difference between the ball and the mitt?
Okay. Remember Newton's third law of motion?
Yeah.
What does it say?
Every action has an equal and opposite reaction.
Equal. So the force the ball exerts on the mitt is the same as the force the mitt exerts on the ball.
Oh, okay.
They are the same, right?
Mm-hmm. Can we do that one together?
Yes, of course. Number 1, yes, of course. So it's an application of something called the principle of the law of conservation, law of conservation of linear momentum. Do you know what this law is about?
No.
Okay. Look, it comes from Newton's laws of motion. It tells us that if no external force is acting on a system, if there is no external force, so F is 0, the momentum of a system is conserved, meaning it doesn't change, it's fixed. In other words, the final momentum is equal to the initial momentum. After all, Newton told us that if you apply an external force, the momentum of a system changes, and the definition of force is the change in momentum over the time taken. So if there is no momentum, I mean if there is no force acting, so there is no change in momentum, as simple as that. Make sense?
Yeah.
Now this is for the momentum of a system. It doesn't have to be one single body. For example, if you look at number 1, I'll tell you, have you ever had a chance to shoot a gun?
No.
What happens is once you shoot the gun, the bullet moves out of the gun, right? With a very high speed.
Yeah.
Right. So it's got a decent amount of momentum. Now what happens is, if you consider the bullet and the gun as one whole system, you're not applying any external force. So when the bullet moves out with a certain velocity, the gun actually moves in the opposite direction so as to make sure that the momentum is still 0. So if you take small m as the mass of the bullet and small v as the velocity of the bullet, that is equal to capital M, which is the mass of the gun, multiplied with capital V, the velocity of the gun. So what happens is, you have your gun like this. I'm not that great at drawing, excuse me. When the bullet moves away in this direction with a momentum of mv, initially the momentum of the system was 0, right? When the bullet was inside the barrel of the gun.
Yeah.
So then, because there's no external force acting on the system, the gun actually recoils in the opposite direction. So that finally, the initial momentum of the system was 0, the final momentum of the system also has to be 0. So you have a small mv in the forward direction, you have a capital MV in the backward direction. Make sense?
Yeah.
Now if you have a look at number 1, you might just be able to solve it. Give it a shot.
I think it's 3v equals 5 times 300.
Yes, that's right. Yes. Because this is given 3 kilograms. It won't be 5 times. This one is given as 5 grams. Now you want to change 5 grams to a certain number of kilograms.
So 0.005.
Right, you want to divide that with 1000. Let's not forget that. Multiplied with 300 is going to be equal to 3 times V. That gives you V. Make sense?
Yeah.